Good morning. Today we're going to practice to sketch the graph and find the properties of a rational function. So when you look at this rational function, you can see that it's an expression 2x plus 5 over x minus 1, but it's not in the right form. So let's transform that first to be able to sketch it and then find the properties. So we know that the right form should be y is equal to a over x minus h plus k. So right now we don't have this form. So we have 2x plus 5 divided by x minus 1. So when we do long division, we do 2x divided by x. So we start with 2x divided by x, and the answer is 2. And then we multiply backwards, so 2 times x is 2x. 2 times negative 1 is negative 2. And then we subtract these two expressions, so 2x minus 2x, we have 0x, so we're done with the x. And 5 minus 2 is 7. So our 7 here, we cannot divide that again by x minus 1 because there's no more x. And then we have our answer plus 2. So this is our standard form. So now with this, we can figure out where will be our asymptote. That means our our h is equal to 1 and our k is equal to 2. So usually we know that the rational is asymptote. Usually the asymptotes are here and here. Now this one has a h of 1, so our h will move 1 to the right and our k will move 2 up. So I'm going to come back to the previous slide so I can show you on the graph. And also because our a is positive, we're going to graph in a regular form, something like this. Now before graphing, we should find, because we're not really sure where our initial value will be and where our 0 will be, so we should find those two before sketching. So to find the 0, if I want to find the 0, I have to find the value of x. So the 0 is the value of x when y is equal to 0. So I'm going to start with my initial expression, which was 2x plus 5 over x minus 1. I'm using this one because that was the original expression. So that way, if I made a mistake in doing my conversion, I can make sure that I'm starting with the right thing. So this is 0 over 1. The easiest way to solve this would be to do this times this is equal to this times this. So that's going to give me 2x plus 5 is equal to 1. So that way 2x is equal to 1 minus 5. Sorry, not 1, sorry, 0, because 0 times x minus 1 is 0. Sorry. So then we get this, and then we get that our x is this. So that means our 0 is minus 5 over 2. Let's find the initial value. So the initial value is y when x is equal to 0. So again, I suggest that we start with our initial expression, but we change our x by 0. So our y is 5 over negative 1. Y is negative 5. So our initial value is negative 5. So now we're going to be able to sketch. So keep that in mind, and we're going to go back to our slide with the graph. So if I'm back here, if you want, you can write down your standard form here to help you. It was 7 over x minus 1 plus 2. So we figured that our h was at 1, or asymptote here. And our second asymptote was our y is equal to 2 here. And we know that we found that our 0 was negative 5 over 2, or if you prefer 2.5, negative 2.5. So this is our 0 here. And our initial value was negative 5. Actually, guys, I don't like when you write 2 answers, so I'm just going to leave 1 here. Okay, so negative 5 is our initial value. So you're able to sketch your graph here. And the other one's going to be similar. If we wanted to graph more precisely here, we can go check what happened when x is equal to 2, y is equal to what? And we can do it quickly if we do 2 times 2 plus 5 over 2 minus 1. So that's 4 plus 5, 9 over 1. So at 2, we are at 9. So there we have 1 point here. And we can do the same to find other points if we want. So let's go. It's going to look like this, something like this. Okay. So our domain, if we remember, the domain is always from left to right. So it's all the values. We have all the values except at 1, because at 1 we have our asymptote. The range is always down going up. So it's all the values again, except when our y is equal to 2, because that's our second asymptote. The variation, remember the variation, you always go from left to right. So if I'm following my curve, it's always decreasing. So it's decreasing on R, except at 1, because at 1 it doesn't even exist. And it's increasing never. Okay. The signs, I'm gonna just use a different color. So the signs, remember this is negative here below. Okay, so the sign, we can say it's negative from minus 5 over 2 to 1. And be careful, the 1 is excluded because that's your asymptote. And when is it positive? In green, it's positive from minus infinity to negative 5 over 2. Union 1 excluded because that's our asymptote to plus infinity. The equation of the asymptote, so be careful, these are equations. So equations of the asymptote, you have this one here, x is equal to 1 and y is equal to 2. So these are your two asymptotes. Y is equal to 2. And to find the inverse, the last question is to find the inverse, we need to switch our x and y. So I'm going to take a different page to show you how to find the inverse. So if you had to find the inverse of this, what would you do? Okay, so first you switch your x and y. You should be good with that one. That's easy. So you should have x is equal to 2y plus 5 over y minus 1. So this so far is good. Now, remember the easiest way to solve this is this times this equals this times this. So let's do it that way. So I would have x times y minus 1 is equal to 1 times 2y plus 5. So remember, if you have a bracket, you need to distribute. So xy minus x is equal to 2y plus 5. Now you see that we have y on both sides. So let's bring all the y on the left and put all the others on the right. So we have this minus 2y is equal to x plus 5. And this is where some of you will be stuck, okay? You'll be stuck because you have a y here and a y here. So what we need to do, we need to factor our y. So if we factor, we bring it in front, what's left in our bracket is this. And this, the next step is easy because how do you isolate your y? You would need to divide by your bracket. So you divide by this on both sides. So that leaves you with your rule of the inverse, which is x plus 5 over x minus 2. So this is the rule of the inverse if you have it in this form. What if you have to find the inverse of this second form? So first you switch your x and y, that you should be fine. So x is equal to 7 over y minus 1 plus 2. And then you want to isolate your y here. So the first thing, you can get rid of your 2. So it's going to give you x minus 2 is equal to 7 y minus 1. This is where probably you'll be stuck. So remember to put this one over 1. So you know this times this is equal to this times this. So we're going to have x minus 2 times y minus 1 is equal to 7. And remember, you're looking for your y. So what you can do is you can get rid of this old bracket here. So you can say I have 7, y minus 1 is equal to 7 over x minus 2. And then, again, you're looking for your y here. So how do you get rid of your plus 1? You would send it on the other side, plus 1. So that's another way of finding the inverse if the form is different. So what I would like you to practice now is to find the rule of the inverse of these two functions and bring that back to class. Have fun!